Glass bottles are made from a mixture of materials, including silica sand, soda ash, limestone, and cullet. Silica sand is the primary component, providing silicon dioxide, which is essential for glass formation. Soda ash lowers the melting temperature of the sand, making the glass-making process more energy efficient. Limestone acts as a stabilizer, improving the durability of the glass and preventing it from dissolving in water. Cullet, which is recycled glass, is added to the batch to further reduce the melting temperature and decrease the energy required for manufacturing, while also helping to conserve raw materials. Each of these components plays an essential role in forming the clear, strong glass used for bottles. In the manufacturing process of glass bottles, the first key step is batch preparation. This involves precisely measuring and mixing the raw materials: silica sand, soda ash, limestone, and cullet. These ingredients are carefully weighed to ensure that the proportions are correct to achieve the desired chemical composition and properties of the glass. The mixed batch is then thoroughly blended to ensure uniformity. This uniformity is critical as it affects the consistency and quality of the molten glass produced in the subsequent melting process. The quality and composition of the batch directly influence the clarity, color, and strength of the final glass bottles, emphasizing the importance of careful batch preparation in achieving high-quality glass products. Once the batch is prepared, it moves to the melting stage, a key part of the glass bottle manufacturing process. The batch is loaded into large, specially designed furnaces capable of reaching temperatures up to approximately 1,700 degrees C. These high-performance furnaces are engineered to distribute heat evenly, ensuring that the solid materials, silica sand, soda ash, limestone, and cullet, melt uniformly to form a homogeneous molten glass. This molten glass glows a vibrant, fiery orange, vividly illuminating the interior of the furnace as the materials combine and transform, necessary for producing uniform and high-quality bottles. The inclusion of recycled glass, or cullet, is a key aspect of the melting process. Once it arrives at the manufacturing facility, the collected glass undergoes an extensive cleaning process to remove any impurities such as labels, adhesives, and other contaminants. The glass is then sorted by color and type to maintain consistency during melting. Following sorting, the glass is crushed into small, uniform pieces. This step is essential as it facilitates easier melting and better integration with the new batch materials. The precise integration of cullet is critical for maintaining high-quality standards in bottle production and optimizing the efficiency of the melting process. Once the molten glass reaches the ideal temperature and consistency, it transitions to the forming stage where it is shaped into bottles. This involves two common methods depending on the type of bottle being produced. The blow-and-blow method is primarily used for making narrow-neck bottles, such as those commonly used for beverages. In this process, a gob of molten glass is first blown into a preliminary mold to form the initial bottle shape, then transferred to a final mold where it is blown again to achieve its final form. This method is particularly effective for ensuring uniform wall thickness throughout the bottle. For wide-neck jars and containers, the press and blow method is employed. This begins with pressing a gob of molten glass into a mold to form the jar's base and lower sections. The semi-formed glass is then transferred to another mold where air is blown into it to expand the glass into the final jar shape. This technique allows for greater control over the glass distribution, making it ideal for jars that require thicker walls or more complex shapes. Each gob of molten glass is precisely cut from the continuous stream exiting the furnace and quickly shaped under controlled conditions in the forming machines. This transformation from raw, glowing glass into elegantly shaped bottles and jars showcases the precision and efficiency of the manufacturing process. After the glass bottles are formed, they undergo the annealing process, which is essential for ensuring their durability and safety. In this stage, the newly formed bottles are passed through a layer or annealing oven, where they are slowly cooled under controlled conditions. This gradual cooling helps relieve any internal stresses that may have developed during the heating and forming stages. Without this step, the glass would be highly susceptible to cracking and breaking due to uneven temperature distributions within the material. The importance of controlled cooling is significant, as it greatly enhances the strength and stability of the glass bottles. By carefully managing the cooling rate, manufacturers ensure that the bottles can withstand normal handling and usage pressures without failure. This process also improves the overall quality of the glass, making it clear and free from defects that could compromise the bottle's integrity. Proper annealing is essential for producing glass bottles that are both safe to use and aesthetically pleasing. Once the glass bottles have been annealed, they move to the inspection phase, a key step to ensure each bottle meets strict quality standards. Both automated and manual inspection processes are utilized to rigorously check each bottle for any defects, such as cracks, bubbles, or unacceptable variations in thickness that could affect the bottle's structural integrity or aesthetic quality. The inspection process employs advanced technologies to ensure thorough and precise quality control. Infrared sensors are used to detect temperature anomalies that might indicate internal stresses or weak points within the glass. Laser scanning provides high-resolution measurements of the bottle's dimensions and checks for uniformity in wall thickness. Computer imaging technology captures detailed visual images of each bottle, allowing for the detection of surface imperfections and structural flaws that are not visible to the human eye. Lastly, the glass bottles receive their final enhancements, such as labeling and painting, which prepare them for market presence. Labeling may involve adhesive labels or direct screen printing, where branding and product details are applied directly onto the glass surface. Some bottles also undergo a painting process to add colors or designs, enhancing visual appeal and providing protection from light exposure. The bottles are then carefully packaged to ensure their safety during transportation. They are placed into boxes or crates lined with protective materials to prevent damage. Each package is clearly marked with handling instructions to guide proper transportation. After the bottles have been inspected and received their finishing touches, they are ready to be filled with various liquids. This process varies slightly depending on the type of beverage being bottled, such as beer, soda, or other beverages, but the general steps are quite similar. The empty bottles are first sanitized to ensure they are free of contaminants, using high-pressure rinsing systems or steam sterilization. Next, the bottles are conveyed to filling machines. These machines are designed to quickly and accurately fill each bottle to the specified level. For carbonated beverages like soda or beer, the filling process must also account for maintaining the correct level of carbonation. This is typically achieved using counter-pressure filling machines, which maintain the same pressure inside the bottle and the filling tank to prevent the loss of carbonation. Once filled, the bottles are capped or sealed. In the case of beer, metal caps are typically crimped onto the bottles, while soda bottles may use plastic screw caps. For other beverages, different sealing methods may be used depending on the product requirements. After sealing, the bottles are labeled and packaged. Labeling can include applying adhesive labels or using direct printing techniques, where branding and product information are printed directly onto the bottle. The bottles are then carefully packaged into boxes or crates, which are often lined with protective materials to prevent damage during transportation. Each package is clearly marked with handling instructions to guide proper transportation and storage. Once packaging is completed, the bottles are ready to be shipped to various markets, where they will be distributed to retailers and eventually reach consumers, bringing the product's journey full circle.